My name is Igal. You maybe know me from the internet. I mention copy everywhere, basically. So I've been doing Scala since 2016. Before that, I was a long time in .NET space, and we did a change. I do some open source stuff. I contribute to Zio, but if you know me at all, you maybe know me from the IntelliJ plugins. I really love breaking IntelliJ and fixing it sometimes. So I work at a company called Unit. Unit does banking, and I'm the first engineer in there, basically the first employee. And we use Scala and functional programming with Zio basically from day one. There are some reasons for that, but I'd like to talk to you about. I'd really like to have a candid, like a serious conversation about, well, basically the state of Scala. And, well, not really, but I just went to TOB or any one of the ranking websites, and I just typed in Scala, and this is what I see. So Scala is not the most popular language, right? It's not a superstar language. It has rises and falls, and if I'm completely honest, Scala is never going to be. It's never going to be more than this right now. But yet we are still here, and we're kind of, you know. I had to actually search for the Scala language. I found it here at number 31, and so the top 20 languages, whatever they are, probably JavaScript and whatnot, Scala is not even being mentioned in the top 20. But we're here. We obviously love Scala for various degrees, and the question is why? What does it really give us? Why is Scala worth fighting for? So I actually went to, everybody got access to GPT now, so I asked to give me an elevator pitch, and this is what it spit out, so I ain't no way I'm reading all that. So there's a bunch of things you can say about Scala. Yes, it's functionalist, it's object-oriented, hybrid, and all bunch of stuff. It has a very, very strong type system. But what does it actually mean? What does it really give us? Now, one of the things that Scala is really good at, in my opinion, is in domain modeling. Now, domain modeling is this very broad subject. If you've heard of the Blue Book, the DDD book, it's a very boring read. If you have attempted it, you most definitely know it talks about products and order lines and things that just make me want to go to sleep. But when we talk about domains, when we talk about things that we want to describe in a language that the business understands, we're going to use some sort of constraint system, some sort of type system to help us in that. But I'm not going to talk to you. I'm not going to talk to you at all about any specific domain. So I happen to do banking, so I'm going to obviously talk about payments. But if we're really honest, all that we do, doesn't matter what company we work for, we are mostly taking things from this side and putting it over to that side. We take an incoming request with a JSON or whatnot, with HTTP or any other transport, and we're putting it in the database. Now, just for this, you can do this with every programming language in the world. In fact, you don't need a programming language. I'm sure GPT can write you a one-liner that does this with some magic framework. You don't need Scala for this. And yet, I would argue that using Scala gives you here an additional benefit that it's very, very hard to achieve in other programming languages that are more popular. Now, before actually going to talk to you about this, just looking at this, can you tell me, other than networking errors and other things that are common failures, what do you think is the problem going from here to here? What kind of things you may encounter as problems when trying to parse this request and storing it eventually in the database? Just anything. Validation. That's a great example. So validation, of course, is something that we have to do because in the end, most of us will probably default to using strings or other primitives. And what happens is that if we constrain our database, our systems of record, in the end, they have the final say. If we constrain them to various lengths for whatever reasons, there might be actual valid business reasons, might be optimization reasons, performance reasons. Let's say we have a constrained model in the database. Now, here, we are given JSON, which is strings. And the thing is, we as developers have to do a lot of mental processing, remembering to either validate our input and making sure that making sure we don't corrupt our systems of storage. Basically making sure our domain remains valid and correct at all times. Now, of course, on the API side, you might have some sort of client-side validation. You might have schemas that handle checking that those inputs are in various lengths or match certain regular expressions. But this overhead is something that always occupies us as developers. We have to keep all of these things in our head. We always have to trust somebody to do the work for us. And I would argue that we don't have to, or rather, we can make all of these decisions, all of the bad decisions, all of the invalid states, so to speak, just impossible. And here's how Scala can help us do this. So let's quickly talk about types. Those things that can distinguish between ints and strings. The Scala type system can do much more, but I want to give you an example. So of course, obviously we all know this thing. You can declare a value of type int, and you can assign it a value of type int, and this is how you prove that you are in fact giving it an int. But did you also know that Scala has another kind of type that matches the value 42? You can do this. I don't know if you knew this, but this thing is a valid Scala code that combines. Every type in Scala, it's called a literal type or a singleton type, but every value in the primitives of Scala has the value of itself. So this is valid Scala code. You can say that x is of type 42. It will be an integer, but you cannot assign any other integer to something of value 42. And this is a very neat trick. It's a nice demo. You might think, well, why is it useful? Well, there's one little thing in Scala called value of. Value of is a function that's built into Scala that can take any literal, be that string or int or any other primitive, and give you its value, its actual value in compilation time. So we talked in the previous talk, we heard a little bit about type classes. So value of is a part of the Scala standard library. And there's a contrived example because, why not? But it lets you, it's a type class essentially, it's an implicit evidence. It's a type class that allows you to specify a static value, a number, and extract that number in compilation and do something with it. So what do we want to do? So let's say, in my request previously, let's say I don't want to use any arbitrary strings. I want to have my own strings that are constrained with a specific length. How would I do this in Scala? Well, we can do it like this. We can create a case class, which has a private constructor. This is important. We can call it string n. The string n takes in some type variable called L, which is constrained to be int. So we're saying we're taking some sort of a type that is integer. Next thing that we want to do is that in the companion object of this type, we want to create a function that is commonly known as a smart constructor. A smart constructor is nothing more than a function that will create the object in a special way, in a way that we control. So this smart constructor will take in any arbitrary string, but you also have to specify the actual number of your maximum allowed string that is allowed. And so this line will check whether or not the string that you passed, if its length is less or equal than the actual number, then it's okay. Then you can create this string n type. Otherwise, you will get an error message on the left. And this thing returns an error. Now let's see how do we use this. So, as you might imagine, if I do string n dot from string, giving it some value of 50, let's say, and I give it something that is a short string, like my name, this will return you a write of string n. Okay, that's obvious. Now, if we try to do this with, like, constraining a string to a number to 3, to length 3, and giving it a very long text, it will fail with the left. That's all nice. Now, what other thing that we can do is teach this to our JSON library. So in this example, we'll use Circe, one of the many JSON libraries available, and we're also going to use derivation. We talked about derivation in the previous slide, in the previous talk. Derivation essentially means I'm telling Scala, you figure it out. So what I'm saying is, for all intents and purposes, the string n is a string. only in compilation I'm limiting its length. But if I want to write it to a JSON or read it from a JSON, this is a string. So what I can say is I can create an encoder that gives me an encoder for my string n by delegating essentially to the string encoder, which Cersei knows how to handle, and giving it the value which is stored in my string n. So for encoding, I'm basically encoding my internal representation, because that's no problem. For decoding, I'm going to have to use a safe, or rather, I'm going to have to use a way that has a possibility of failure. Because if I'm trying to decode an arbitrary string, I have to prove that this string is less than or equal to the length that I'm actually expecting. And so Cersei has an emap, which is a variant that takes something that expects an either. So basically, it's given some raw input string, it will expect an either a string failure or a success of type A, in our case, the string L. So by adding those 2 lines, and there are 6 lines in total, I now have a type that is capable of representing a string that's limited in length, and this is enforced by the compiler. What do I do with it? And now, I can go to my domain objects, whatever that means, and I can create case classes that have private constructors that instead of just wrapping strings, they can wrap those string n 255s, because in my request, in my data model, I have the recipient name, whatever that means, to be bound by 255. So it's a private constructor, I cannot create it from any other place. I have to go through this from string, which is another smart constructor. Here I can do additional validation. If I'm an advanced user, I can use validated from cats or use any other sort of validation to perform any additional analysis. For instance, let's say my string always has to be in ASCII characters only, so I have to strip emojis or whatnot. You can do this by performing this validation here. This validation doesn't have to be defined in the object. It can be external. But the point is, the only way to create a recipient, a valid recipient name or any other entity in my domain is going through the private constructor, is going through the smart constructor, is going through the actual option or either and succeeding. Now, for advanced users, you might notice that creating case classes might be, it creates an instance. We don't want incur all of those allocations. So there's a library that's called newtype, which is a macro. I'm not going to expand on it right now, but if you are importing it and you mark your case classes as new types, those do not exist in runtime. Those only exist in compilation. They basically give a name to the string n, but in your compiled code, it will all be string n. It's just n and it's zero cost. It's basically a zero cost abstraction. All right? So finally, after having this, defining all of the values in your domain model as cheaply as you can see here, essentially, you don't have to do much. You can create a whole bunch of case classes, wrapping all of those string ends, and if you want, you can have new types on top of string ends. For example, you can have a numeric string end, for example, or a numeric string. That it's a string that's limited by length, but it also has to contain only numeric characters. You can validate this with regular expressions if you want. But once you have all this, what you can do is essentially for free, is that when you have your payment request, it can be in any framework that you want, in any HTTP framework or gRPC or whatnot, your request object will not contain all those unbounded primitives like ints and strings and whatnot. It will have your case classes that you've defined with the smart constructors. And because each of those case classes defines its own encoder, or actually derives its own encoder from Cersei, all you need to do is you need to do this, which is called a semi-automatic derivation. You need to say, I want a decoder for this type, and Cersei will do everything. And finally, what this gives you, with relatively small amount, like relatively short amount of work, this will give you, as you expect, if you try to do a post with something that for some reason failed all validations in the front end, and somehow you ended up with this big number, you will simply get a decoding failure from Cersei. Now this is a very low level error. What you might want to do is you might want to catch it in your HTTP handlers and whatnot and return a bad request to the user and convert it to some other form of meaningful representation. The point is this. I took away all the notion of things being capable of failing. I don't need, the point is this. I do not let anything that didn't pass my initial validation into my system. This will fail at the gate, at the entry point. I will not be able to actually meaningfully use any of this data if it did not pass my initial validation. And this allows me, basically, to be very, very precise and essentially encode all of my, I don't like the term business domain, business rules, but it essentially allows me to state at a very rudimentary level what are my invariants? What are the things that cannot possibly change? And I encode them in types. If you ever heard about type-driven development or something that's actually showing you how Scala can use those types to your advantage, this is how. You don't have to go to crazy macro libraries. I'm going to mention them because you don't have to write any of this by hand. You can use libraries today. There's libraries called Refine, or if you're using Zio, there's Zio Prelude, which provides you all of this out of the box. You can essentially don't have to create your own string N, and they give you smart constructors for free. The point is, doing this at the very, very lowest levels of your system, at your it's in domain-driven design. It's called the shared kernel of functionality. You can put all of these primitives down there with all of these derived encoders, and then you can build your entire system, all of your later for whatever domain that you are using, be that payment processing or building websites or managing time off in your HR system. Whatever it is you want to declare, you can describe it using those precise types. And what this relieves you is this relieves you from the cognitive overhead of caring. Did this pass validation? Is this string going to blow up when I try to persist it in my database? Is this going to blow up when I try to read it back? I don't need to worry about it because as soon as it enters my system, I know, because this is the only way that the Scala's type system is going to allow it. I know that my routing number will be at most 9 characters, and nothing else is actually possible by construction. This is what it means to be type-driven, because you are constraining those things inside the types and preventing constructing them with invalid data. So there's much less unit tests that you have to do. You don't have to write manual tests for things that cannot possibly compile. You don't have to recheck your work to ensure that your strings are too big or whatnot, because it's stated in the type system, and Scala will not let you bend this in any other way. Finally, this is teachable. It took me 10 minutes to write this in slides, and as you can see, I just took the default template because I don't really like making slides. You can teach this. So if somebody comes to your organization and they're not familiar with Scala, maybe they're coming from another type of background, maybe they've been using Java or C# or Python or JavaScript, they are not familiar with the concept of using more types to your advantage. And so at Unit, where we work, we mostly hired people who don't come from a Scala background. We ended up with hiring fantastic engineers, but most of them came from other environments. And it took time to kind of get them familiar with all of these concepts. We use at work all of these concepts and much more. But it takes time to kind of convey this information and teach it. And so if there's a couple of tips that I can give you that will work for us, is that if you find yourself, so you're obviously going to have people who are more experienced, who are more knowledgeable in various frameworks or tricks. If you find yourself answering the same question more than once or twice, just do a little Zoom session, record your screen, try to explain it, and then put it in somewhere in internal Slack channel, or create your own YouTube channel, make everything unlisted, and so nobody can view it from the outside. Or, God forbid, you can put it in the drive, but I claim that drive is where content goes to die. So make it more accessible. And then if somebody else has this question, you can just point them to the top, point them to the session. Now when you're onboarding new engineers, and everybody is responsible eventually for onboarding. You don't want to leave a candidate just coming in and sitting by themselves, working through your course materials. There has to be human interaction. So it's up to you to observe it, get feedback, request feedback constantly about the onboarding process, and constantly refine it. Things get out of date really, really quickly, especially in Scala. What you want to understand is you want to see where people get tripped up, because not everybody will have the same process of getting all this stuff, because this is very complex and people create metaphors and analogies, and until the penny drops, it will take different approaches to do. So work on refining your onboarding material. Do invest, and I highly recommend it. Try to invest in paid courses that you can find by nice folks in the industry like Rock the JVM or Zyverge that do trainings. They provide videos and workshops for actually making sure that this stuff is understood. Rock the JVM has a fantastic intro course to Scala, right? Both free and the longer version, which is paid. I highly recommend those. If you're trying to teach somebody, trying to show somebody actual code snippets, try to use interactive playgrounds like Scasti. Scasti is like this web editor where you can write Scala code and just will compile in the backend. So you can just leave things unimplemented, and they don't even have to have IDE set up yet to do this. And the point is that Scala talent is not in great availability. People from UMeta will tell you. Scala, because I don't believe that Scala is going to have this renaissance. It's going to have this resurgence of popularity as it had a couple of years ago. I think the biggest success story that Scala had was Twitter, and Twitter is no longer with us. It's called X now, and I think I'm not even sure how many Scala engineers remain in Twitter today. So Scala is not going to get better, and yet I really believe that I just showed you one little thing that Scala can do for you today without anything really. You can just do this as a lunch session tomorrow at work or Sunday at work. But my point is, if there's one point to take away from all of this presentation, is that you are responsible for Scala in your organizations. There's nobody else. See, I changed the team here, so you know that this is important. The point I would want to make is that you all are the only people who basically are going to fight for Scala in your organization. If you believe that it solves real business problems and in a way that it's really worth investing, then it's your responsibility to basically make sure that everybody else understands this. This is not going to be an easy process. You will have forces working against you, trying to move you away from Scala into something more popular, giving you excuses ranging from hiring talent to not being able to maintain all of this code. So I deliberately not used many of the crazy syntax. Of course, you know, like like I said, you could go and use all of these libraries that already exist and jump straight into the more advanced stuff, but you don't have to. You can start with these, explaining these concepts, and then you can see, okay, so in order to use these concepts, I have to use a little bit of boilerplate. Let's eliminate the boilerplate. But you only eliminate this boilerplate once everybody in your team, or at least a major part of your team, understands the inner workings of these things and the purpose why we have them in there. So with this, I left a slide for water break, but somebody took my cup, so I'm just going to wrap it up. My point is, if there was one, that Scala is not the most glamorous, but it's very powerful, and I think it gives you a lot of benefit to the business, as boring as it may sound, but it gives you something that's much more than an intellectual satisfaction. Everybody loves Scala because it can be clever, it can be really maybe mathematical if you're inclined to that sort of thinking. The business doesn't care. They don't care about all of the neat stuff and all of the libraries that solve. Business care about not losing money, and they care about making money. and they will find a way to do this with or without Scala. So with that, I am going to leave you with a little bit of homework that I urge you to look at. And it didn't add any links, but you can take a photo of the slide, and the slides will be available later. So first of all, I would recommend you to read this book. It's called Domain Modeling Made Functional. Now, this is written for F#, which is a Microsoft language that works on the JVM, but it talks about this notion of making your domain as precise as possible, and it uses F# as an example, but it talks a lot about these things, a lot about these type refinements, making sure that you speak in a precise language that the business understands, and this way your code, your systems will be much more resilient and have much fewer invalid states in them, so it will be correct by construction. The other book is a more recent one by my friend Gabriel. He wrote a book called Functional Event-Driven Architecture, where it takes, this is in Scala, and it's using CATS and Scala 3. It puts everything and then some into this one big project that I believe it goes into an e-commerce system. It will show you all of the tricks in the book, how to precisely use refined types, just as I showed you, and new types, and how to do derivation, and how to do everything everything to make a system that's just robust and never goes down, which is amazing. Finally, there's a shortened talk by Gabriel. It's called Why Types Matter. It goes into somewhat of a more detail of how to do this tricks with refined types. And as a bonus, recently I recorded internally, one of the sessions that we do internally at work is I recorded a session in Hebrew about implicits and type class derivation. Something that's very similar to Matan's talk today. So if you really want, if you're not tired of hearing me speak yet, you are welcome to watch that. I'm going into a great detail about how derivation works and how Scala resolves implicits and whatnot. You will gain better understanding. Finally, if you learned anything today from my talk, first of all, thank you so much. I'm humble, and please go and explore these libraries, explore these topics. Do a session on them internally at work, record it, share this knowledge, and this is how you keep Scala alive in your organization. So, before taking your questions, if there are any, I wanted to again thank you all very much for staying. This was kind of a stream of consciousness talk. I really want to give a big thanks to you, Meta, for organizing this wonderful event, and to Bob for hosting us here. Let's do this again soon. And with that, if you have questions, I would love to hear them. If not, good night.